Hello, everyone, and welcome to tecBites Thursday. My name is Clara, and I'm very happy to welcome you all today. Every month, we bring in industry experts to discuss the most recent IT-related topics, and I'm very happy to welcome Matthias today. Matthias brings more than 20 years of experience in software architecture, works as trainer and consultant, also for us at tecBites, and he will give us a better picture on how AI is changing IT-driven, AI-driven projects in software architecture. And we will have a very interactive webinar today, so there will be interactive elements as well as learning nuggets in the very end. So with that, Matthias, I hand over to you and enjoy the webinar.
Thank you, Clara, for the nice introduction, and thanks for having me here today. We'll talk about a pretty exciting topic, the situation when a software architect with enough experience for classical projects is suddenly being asked to join your first AI project, right? The project where an AI is contained in your system. So you might be scratching your head here and saying, oh, what do I need to do in order to prepare for such a project? And we will talk about this today. It may feel kind of uncomfortable because you have been here before. You know all these situations, like a new paradigm arrives, everyone panics, is very excited, like about AI this time. And as an architect, you need to adapt to the new situation. You've been there before, like with microservices, cloud native, event-driven architectures, whatever it came around the corner over time, you survived them all, I think. But this time it's different in one key way. The system is really learning, the system adapts, and so you don't control its entire behavior. It's not like you're writing the code and the system is simply executing the code, but in the middle there's an AI-based component which has a kind of autonomous behavior. So you don't have everything under control this time. Your instincts, be assured, are still valid. So your design instincts that you know, like coupling, cohesion, and all these stuff that you already have learned. But I think your toolbox might need an upgrade to survive an AI-based project. Here we see the typical tasks that my friend 𝘃𝗶𝗄𝗃 has written down, the typical task of you as a software architect. You may be clarifying the requirements by talking to the stakeholders, helping them really say what they want and what they need. Then you go ahead and design proper architectural structures, like, for example, the module structure of your system, or the runtime structures, or deployment and networking. And you also design cross-cutting concepts for all these things that have nothing to do with a particular component in your system. For example, like logging, tracing, security mechanisms, usability of the system, the ability to monitor everything, and so on. So you've got your structures in place, you've got your cross-cutting concerns in place. And once you did that, you communicate your architecture. For example, you write it down, you talk about it with other people, you share it with them. And after a while, it goes into building stuff, implementing stuff. So as an architect, you are shepherding the developers, helping them to build all this. And finally, when project is running, every few months or so, it's a really good idea to analyze and evaluate your architecture to find out whether it still reflects the current requirements, which might have changed. So this is all the stuff you already know as an experienced architect. You know how to do these things. Now, the first question to ask when you join an AI project, you should ask the question, is it machine learning? Do we have a machine learning model, traditional one? Or do we have generative AI? Because these things are not the same. With machine learning, you train a model to predict or to classify something specific. Let's say prediction is about sales numbers of next quarter, right? Management might want to know how many, how much. Or classifying. Let's say you give the AI a picture and it says, yeah, this is a cat, or this is a rabbit, or whatever. So it's a classifying task. With generative AI, it's different because you can already build on top of a model that already knows things. So big models like ChatGPT, like Claude, but also smaller ones like Qwen, for example, or Minimax these days. There are hundreds of them that you can already use, and you don't need particular amount of training for them. You can simply fine-tune them. So what has changed here? I have prepared a drawing surface for you so that I can show you some things. For me, the biggest difference between classical software engineering and, let's say, a machine learning based project and a generative AI based project is this. In classical software engineering, you've got some input data, right? And it goes into a kind of function, and some output data is coming out. And in this scenario, you as a developer or architect are writing this function called f, right? So you're responsible for the behavior of the system. In machine learning, it's different. We've got the input data again. So you're responsible for the input data. Then you run that input data through some model and you get some output. In this case, you're responsible for the output data. You give it to the model, and the model itself is learning. So we could say that the model writes the function, not the developer writes the function. So this is really a big change. You provide input and output and let the model learn what's the mapping function from input to output. And finally, with generative AI, you provide the model with some context plus some new input data. So you're responsible here. You give it to the model again, which has been trained before already. So big companies have done that for you. And now you've got some output. And you're also, looking at the output and might suddenly be confused by what is coming out of the model. So here you have even less control. So be prepared for a change from here to there and over there, finally. This makes these projects so interesting. So let's go back. Now, what happens? So you need to ask, am I going into a machine learning or an AI project? This is only one of the questions. So here at the top, we see what kind of questions would you like to be more sure about before starting the AI project? Please leave the questions. Please think about your questions and tell us about them. We are very curious about what are your questions. Meanwhile, I'm continuing the presentation here. Okay, so getting this fundamental difference wrong between machine learning or GenAI may lead to the wrong architectures entirely. So be very clear about this. Good. So let's have a look at a typical machine learning project. It happens in an environment called the machine learning engineering lifecycle, which we see over here. I also have prepared the same picture here on my table for you, so that I can explain. Here we have three different kind of pipelines. Here, this one is called the data pipeline. It's more about data and preparing it. Here in the middle, we have the machine learning pipeline. And down here, we have the usual software and code pipeline that you already know. So let's start at the top left. You've got some significant data from some of your systems, for example, from your databases, your data warehouses, whatever, data lakes, data meshes that you have in your company. Data scientists and machine learning people, they are working to explore and validate the data. They are cleaning it, getting it high quality, or the fields have the correct syntax, or the fields are filled, no missing values, plausible stuff, and so on. So they finally reach at this big box that says data. It's versioned data. They split the data into a training set and a test set. The training set is then presented to the model. So they are doing, now in this machine learning pipeline, they're doing model engineering, finding the right model, configuring it, hyperparameters, etc., etc. Then they train it, and finally they evaluate it. Is it a really good model? Does it make good predictions? If that is so, they put the model into a kind of package. So here we have this big box that says the model. It's a versioned model. And now it's entering the software and code pipeline. You write some code, your real application code as you did before, and you package it together with your model in a build and integration testing machine. And then you can go to deployment in production. So you might think the thing is over now, everything is green. No, it's not. You have to monitor and log everything what happens in production, because the model might be behaving in a way that is unexpected when it really sees the real world production data. So in this case, you get feedback. You have to give it back to the data science people. So if the model is doing some incorrect stuff, then they might need to adapt and run the entire pipeline again into production. So this is a feedback cycle here. So for machine learning projects, be prepared to make this work. So let's go back to the slides for a moment. So this was your first learning nugget. In traditional software, a bug is a mistake that you make or the developers make. In machine learning, a bug can be a pattern that your data taught the system, right? The data was formed in a certain way in the system. The model learned something which turns out to be a bug later. And it might have been in production for months before anyone noticed. Imagine your company is running some fraud detection model that wants to detect fraudulent transactions in your e-commerce store. You have it in production, it works, it really predicts fraudulent transactions, but suddenly these fraudsters, they change their tactics over time, right? Half a year later, they are using different mechanisms with wrong credit cards or whatever. So your model is making the wrong predictions for 6 months later. And you might not have noticed. So this is really a big difference to traditional systems. There's no test that fails. There's no error message coming up. Just the behavior of the system changes. Good. So what do you need to do? Let's look back on these two graphics that we have seen now. The task of a software architect on the left side, that's what you will do. And the data science and machine learning colleagues on the right will do the machine learning engineering cycle. So in this case, your boxes that you draw on the left in your structures and cross-cutting concepts and so everything, they have to support the boxes on the right. So the data box, the model box, the code box, whatever the machine learning experts are creating on the right side, you have to support them with the correct structures in your design. Good. Now let's switch to generative AI. First of all, the question to you, what kind of use cases would you use GenAI for? So what can you imagine that GenAI can do for your company? Please leave some ideas in the comments. We're very much interested in that. I brought some architectural patterns for you. For example, with generative AI, you can do interesting things like retrieval augmented generation. It's a kind of mechanism where you let's say the user is asking asking a question, like they want to go into a hospital and they don't know where they can park their car. So they ask the AI, a kind of customer support bot, where's your parking lot at this hospital? And retrieval augmented generation means the customer support bot goes into a database with all this help text, pulls out the right information about the parking lot, and generates some friendly comment for the user that says, turn around 3 corners to the left, there is the parking lot, right? So retrieval augmented generation is a mechanism to give fact-based answers, not hallucinating them, but giving them fact-based. Function calling is an interesting thing. You can tell the generative AI that it has a number of tools, a number of functions which it can call. For example, it can search the web, it can read files, it can write files. You can give it all kinds of agency. And here it's very important to be careful. Don't give too much powerful functions to your model, because we have heard the stories from Meta and other companies where suddenly AI was deleting old emails and the history was lost and everything. So don't give too much power to your AIs. Fine-tuning is a good mechanism where you can take an existing model that already knows lots of stuff. And with fine-tuning, you can tune it to your particular use case, right? So for example, if you're selling products in a certain domain, let's say bicycles, you're selling really high-tech bicycles. So you can fine-tune your model to talk about bicycles in a very informed manner. So fine-tuning is a good thing to save a lot of training work. Assistants and agents, finally. Assistants, you already know them, like ChatGPT. You ask it something and it answers you, maybe already with memory and context behind it. And agents are really built on top of this. Agents, they can develop an autonomous behavior. They can react to unforeseen events, make new decisions, go into a different way. The last few months, things like OpenClaw, for example, they have become very famous. You can put OpenClaw on a machine and it does, really almost run your entire company for you if you want. With agents, you have to be very, very careful. Put guardrails in, really design a very secure and safe environment for the agent, because it has agency, right? It can decide on its own. Good. So here you have 5 mechanisms that you can use for your use cases. There are even more, but we don't have much time for this today. So one learning nugget number 2, a retrieval augmented generation pipeline that we had in the previous picture is just a search engine and a language model shaking hands, right? The user asks something, the search engine searches the needed information, and then the language model is talking about the needed information. So once you see it that way, you can start to design RAG mechanisms. Okay, so what is one thing that I would recommend you must do before going live on a project? I really can recommend to build a prototype. Try it out by yourself before even sprint 1 of your target project begins. Because you can't really architect what you've never touched, right? Go ahead and use some public data sets. For example, download them from Hugging Face or from Kaggle or from other well-known places. Here in Germany, for example, we have public data sets about all the lamps in the streets. There are big databases where each lamp is being recorded by the city. You know exactly where the lamp is and whether it works or not. So it's interesting what you kind of find as public data sets, weather data, traffic data. So download some interesting data set for yourself and download some open models, let's say Llama or Mistral or whatever you can find. Hugging Face has a lot of machine learning models too, where you can try to make predictions or to make back classifications and so on. So run them on your own data sets to find out how they react. It's really good to spend a weekend breaking things, trying out where's the limit. That's really the point, getting ready to architect these things. I'm not saying you can do this in a weekend, so it takes a little bit longer, but a weekend is a good first sprint, so you can break some things. What you will learn, you will see latency surprises, token costs, the retrieval quality will be sometimes good, sometimes bad, and every model will have its quirks, right? Some models are better for these purposes or not so good for other purposes. You will notice that. So try a lot of things, try to find out, try to break it. That's a really good experience. Because in general, I always say you can't design for failure modes that you have never seen, right? You can't design a proper structure because you will be surprised what happens in production. Maybe it's also a good idea to work with your data science and machine learning people that you have on the project or will have on the project to get some more experience. Good. So your upgrade path for the next few months, maybe for this quarter or so. So if your project is a machine learning one, then go and learn machine learning operations, MLOps, similar to DevOps, but with a different focus. Learn about what is a feature store, how does the pipeline orchestration work with Airflow, Kubeflow, all these interesting tools. If your project is more like GenAI, then go and learn about retrieval augmented generation, agent frameworks like LangChain, Llama Index, and so on. There are even more modern things than that. And learn how to evaluate an LLM, that you really can find out whether it fits your use case or not. If your project is both, yeah, you need to learn all of the above and design for the seams in between, right? There could be a seam between the machine learning and the GenAI model. A good idea is to start with a prototype, to pick one pattern that you want to learn and prove, and then ship something fake to learn something real. Create some small application, show it to your friends and family, and try to find out whether it's useful or not, whether the predictions that come out are useful or not. Good. So what does this mean for you as a software architect? As a summary, I could say the rules have changed. The role of the architect didn't change. So architects still own the structure. Things like reliability, observability, the decisions you need to make, nobody else will make them for you. And AI systems, they don't remove that responsibility. They raise the stakes for it, right? It becomes more complex. It becomes more unpredictable, more statistically reacting than predictably reacting. So yeah, AI raises the bar here for you as an architect. And the architects who learn this now will be the ones that people will trust to lead those projects that come in the future. So it's your move now. Go and learn, prepare for your first AI project, try out some things for yourself, and then it will work. Good, so fingers crossed for me. Best wishes for your concrete projects, and please let me know what happens in practice. I'm so curious always about real stories from real projects. So I would be happy to hear more from you. Thanks.
All right, let's wrap that up here. Thank you, Matthias, for all the insight and making the topic so accessible for all of us. It was very, very easy to follow you throughout the webinar. And also thank you to everyone who joined the webinar. It's always great to have participants here, and you always have the chance to rewatch the webinar if you know someone who this webinar might be interesting for. Feel free to share the link even after the webinar finished. Other than that, we want to invite you to follow tecnovi on LinkedIn, but also on our other social media channels. We are on Instagram, even TikTok, as well as that we post recent updates on our website. This is a regular webinar series, so we will have a lot more episodes to come. And if you like the webinar, I'm very happy to welcome you in the future again. That's basically my final words. Have a great afternoon, and see you soon.
Thanks, Sarah and the team. Bye-bye.
Thank you.